All right, fellas, let's go ahead and get started with this assignment. For each for each of these, you need to um, graph the terms, write the explicit formula, and then write the recursive formula. So the basic idea behind each of these practice problems is that you need to be able to write an explicit formula, which is going to require you to have the zeroth term and the common difference. And then from there, you can write the explicit formula. After which time, from there, you can also use what we learned in class to write your recursive formula, which fortunately for you has a start right there at the where it says recursive formula. Right, so let's go ahead and get started with the explicit formula. So you do have a sequence right here. Right, that's your sequence. First thing I would suggest is that you figure out how to go from one term to the next term. So for example, how do you go from 4 to 7? And if you're saying that's going to be adding 3, then I would say wait up, let's try it one more time, figure out how do you go from 7 to 10. And if you say adding 3, then I would say, hey, you know what, getting closer, let's try it one more time. How do you go from 10 to 13? And if you're saying adding 3, then I would say you got this. Right, so that right there, the plus 3, that is your common difference. Oops. And you will write it as a 3. Okay. Now what you also need is you need term 0 if you're going to be successful in writing your explicit formula. You need to go backwards. So you see that 4, 7, 10, 13. Well, your term 0 is going to be the term that comes before all of those. Okay, what term comes before the 4? And if you're finding the next term by adding 3, then you can totally find this by going backwards and subtracting 3. So you can go and do 4 minus 3, and that will get you 1 as your common, or actually, sorry, as your term 0. So term 0, you can write that as 1. So now you're ready to write your explicit formula. Explicit formula starts with T of n equals, right, equals your first or your 0 term, which is going to be 1, plus your common difference of 3 times n, right? Now for your recursive formula, you don't need term 0, so you don't need to actually write down term 0 or even list it or even acknowledge it. Okay, your recursive formula relies on knowing the first term and then how do you get the next term after that. So right here where you see it being started up for you, you will see term 1 is equal to, and you look here, term 1 is actually the first term that you see, which is 4. So term 1 equals 4, and then you also see term n plus 1, that's just the naming convention of how to get to the next term. Well, that's the next term's name. So how do I get to the next term after I started with 4? Well, I would take the current term, t of n, and I would just simply add 3 to it. And that's how you write the recursive. Recursive formula contains 1, 2 equations, right? Explicit formula contains only 1 equation. Keep that in mind. Right? So now we're going to go ahead and graph this. Right? So this is your x-axis. This is your y-axis. I will start with the x-axis. X-axis is easy to label because it's just 1, 2, 3, 4, 5, all that stuff. This is just your term number. Now, if you look at your y's or your term, okay, they go all the way up to 13, and that's for term 4. Right? So what I usually do is I usually use what my common difference is, and I use that to kind of help me gauge how much to graph, or how much each tick mark along the y. So if that's 1, or excuse me, if that's 3, then I would start with, so from 0 I would go to 3, 6, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, right? So I would be going up by 3 because those are going up by 3. So it's kind of like this. So that's what I use to kind of help me gauge how much I should be graphing, because it helps me kind of fit everything onto my graph. So if I'm doing that, my first term is 4. So my first term is 4. So 4 is a little bit after 3. My second term is 7. So 7 is a little bit after 6. So my second term is 7, which is a little after 6. My third term is 10, which is a little bit after 9. In fact, they're all a little bit after the next number, right? So after 10, at 4, it would be 13, which is a little bit after 12. Right? And if I do this, and if I even graph my 0 term, which is going to be 1, right? So remember, the 0 term shows up right here, and it's 1. So my 0 term, and 1 is a little bit before the 0. And you can see that if I was to draw a line, which I don't need to, I would have a straight line. Okay, number 2, again, kind of just taking a look at this, we're going to try to figure out what happens from 24 to 19, and that right there. You can pause this video if you need to, if you don't want me to ruin it for you, but 24 to 19, that looks like it's subtracting 5. And then from 19 to 14, that looks like subtracting 5. So it looks like, I think we have our common difference of -5. Okay. And if we need to find the 0 term, or the term that sits right here before the 24, we need to go backwards, and instead of 24 minus 5 to get to the one behind it, we're going to go 24 plus 5 to get to the number that comes before the 24. So 24 plus 5 is going to give us 29. Right, so term 0 is going to be 29. So with that, we can write our explicit formula, which is T of n equals the 0th term, which is 29, plus, and then the -5, which is our common difference, times n. You can see how I have a plus minus, and that looks a little messy. And you can leave it there, but if you clean it up, it is so much nicer. 29 minus 5n, and that's a cleaned up version of it. All right. If I want to write my recursive, recursive starts with term 1, or at least that's how we're choosing to write it. So we want to say term 1 is going to equal, and the first term is 24. And then you can write the next term, which is term n plus 1. That represents the next term. That's going to be, you're going to find that by taking the 24, or what we call the current term, T of n, and what we're doing is we're just adding a -5. So we can just write -5. And that's your recursive. So again, this is your explicit formula, and this is your recursive. Your recursive formula has 2 equations. Okay, again, and how I was kind of showing you guys how to mark the x and the y. Right? The x, you can just mark it as 0, 1, 2, 3, 4. The y's, okay, the y's, you see how I'm going up by 5, right? Or going down by 5. Well, you can still do that. You can count by 5. So 0, and then it'll be 5, 10, 15, 20, 25, 30. Okay. This helps you get good numbers. So my first term is 24. So see how my first term, I can go all the way to 24. 24 is, oh, sorry, messed that one up. 24 is slightly below the 25. So 1 would be 24. You can see how I have good spacing now. And I don't run out because I've kind of used my my common difference to kind of help me gauge my tick marks, right? So term 2 is 19. 19 is slightly below the 20. term 3 is 14. 14 is slightly below the 15. You see how they all make a straight line. And we don't have a term 4. We can find it, or we can just kind of leave it alone. But we definitely need term 0. And term 0 was 29, which is slightly below the 30. You can see it's going to make a line. All right. Okay. And the last one, let's go ahead and first you want to analyze how it's finding the next term. So for example, from -3 to -9, that looks like it's going down by 6. All right, so between between -3 and -9, looks like you're going down 6. And then between -9 and -15, looks like you're going down 6 or more. So it looks like we do have a common difference of -6. And now we want to find our 0th term. So we need to go backwards, which means that we're going to have to go in from -3, we're going to have to add 6, because that is the opposite of -6. Right? So that's going to get you, so you put in your calculator or whatnot, -3, if you add 6, you should get 3. And so term 0 is actually 3. So your explicit formula is going to be term n, or any term you like. That starts with term 0, which is 3, plus your common difference of -6 times n. And again, you can clean that up by making it into 3 plus, 3, we're trying to clean it up. So 3 minus 6n. Remember, that's only one equation. Our recursive formula is going to rely on the first term, which is -3. Remember, not this one. This is my 0 term. So we want our first term, which is -3. And then to get my next term, we have to go and rewrite this as term next 1, right? Or tn plus 1 is going to be your term next, or your previous term. Then what's happening is we're going to be subtracting 6. So this is going to be your recursive formula, and notice that it's made up of 2 equations. Okay, again, I like to go and utilize my jumps as a kind of like a guideline. It's not the best, but I mean it actually definitely works for how much you need to you write between the tick marks. So on the x-axis, I would write x is pretty simple because you do need your 0 term, 1 term, 2 term, 3 term, 4 term. But my y is a little harder. So my y, I will start with -6, -12, -13, 14, 15, 16, 17, 18, -24. And it looks like it's too much right here already. -30, -36, right? You can see that my 0 term is going to be 3, and 3 is going to be, if I was looking at all 6, 3 would be halfway. I was looking at all 6, 3 would be halfway in between. But that's +3, so I need to be above right here. And my next term, so at 1 would be -3, which is going to be halfway. At 2 would be -9, which would be halfway. You can see that this actually does work. At 3 would be -15, which would be halfway between -12 and -18, so it would be halfway in the middle. And that looks like about it. All right.